Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! The first piece of information I'm going to focus on is the fact Denver gets 8/19. Denver gets 8/19, that means that Engel and Fido together must get 11/19 because they have to add up to 1. So we're only looking at 11/19. I'm going to focus on the ratio next of Engel to Fido. So it's 9 to 5. And let's have a look and see, well, first of all, how many parts there are all together. So 9 plus 5, which is 14 parts. So there are 14 parts in total, and the share that they get is 11/19. So what I'm going to do is to find out what fraction one of those parts is worth by dividing 11/19 by 14. So each part is worth, and I'm just going to keep this into my calculator, 0.041 blah blah blah. And we're asked to find Fido's share. Well, Fido has 5 parts. So Fido has 5 parts, each of them worth 0.041 blah blah blah. I've kept it in my calculator to keep the accuracy. And when I do that, I get 0.206 blah blah blah. And we're asked to work it out as a percent, so I'm just going to times that by 100. So we have 20.676 blah 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 percent, and it wants it rounded to the nearest percent, so that would be 20%. Or actually, it would be 21% because this would round it up, so 21%. We need to first of all work out the theoretical probability. And to do that, we do the successful outcomes over the total number of outcomes. So here we're asked, it lands on a red is successful, so that's going to be 15 over the total amounts. That'd be 40 plus 30 plus 15, which is 85. Okay, now to find the expected amount, it's just the theoretical probability, which is 15 over 85, times the amount of trials, where it says it's spun 500 times. We just go times it by 500. And we get the answer of 88.235, blah, blah, blah. And we're always going to round that down. Okay, so if it's 88.9, we're always going to round it down to 88. Only when it gets to 89 do we write 89. So our answer is that we're expecting roughly 88. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000. So that would be 9. 0, 0, 0, 0, and so we're just subtracting them like that, and so we'll get 6991000. And obviously, if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. So let's write these numbers out. And the first thing to do is work out what the numbers are going up by. So they're going up by -3 because they're minusing 3 each time. So we know that the number before the n is going to be -3. So whatever they go up in is the number before the n. Then what we do is we go backwards to find the 0th term. So actually going backwards, we would add 3, and we would find it to be 20. So whatever numbers our 0th term, because 17 is our first term, is going to be what we add to the minus 3n. So it's going to be add 20. So our answer is minus 3n plus 20. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So w therefore equals 4. The first thing we need to do is work out the area of the floor. And you'll notice that this is a trapezium. So with a trapezium, the formula is half a plus b times h. And a and b are the parallel sides. So these ones are the parallel sides. And the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula. So it'd be half a plus b h. So half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack. So we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence. So I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. So if we imagine we've got the 25 metre pipe here, and we've got the 35 metre pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length, that will fit with the 25 metre and the 35 metre. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 metre pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 metre long, and there's no wastage, and that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 metres. To work out the mass, we will need to find the density and the volume. Density is given to us in the question, but volume isn't, so we need to work out what the volume of this cuboid is. So the volume is just the 33 times the 7 times the 22. So that would be 5,082, and that would be centimetres cubed. And we need to write down the formula for density. So density is the mass divided by the volume. So rearrange this to get mass on its own, because that's the thing we're looking for. So mass equals density times volume. Density is given to us in the question as 2.1 grams per centimetres cubed. Times that by the 5,082 for the volume, and we get the answer of 10,672. And then that will give us grams, because our density is in grams, so that is grams, but the answer is asking for kilograms. So to convert that to kilograms, we just divide by 1,000, and we get 10.672. Then we need to round that to 2 decimal places, and so that would be 10.67 kilograms. So we're asked to find the bearing of Freetown from Gamley, so that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got 90 degrees here, we've got hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out, and we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA, and so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in, and we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around up until this point is 270 because we've got this 90-degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434, blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4 w to the power 5, it's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4 w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4 w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times two powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8, w to the power of 10. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10, 990. Now when we're looking at limits, with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that v can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. Okay, so we're going to start off by working out the multiplier, and we're told, we always start off with 100%, we're told that the compound interest rate is 1.6%, so we're going to add 1.6% to the 100%, and it's going to be 101.6%. Okay, make that into a decimal by dividing it by 100. So we're just going to divide that by 100, and this will give us the decimal, or the multiplier. So the multiplier is 1.016, and so anytime we want to increase something by 1.6%, we just times it by 1.016. Now, we're told that we start off with 2,400, that's our original amount, and to find out what it's going to be in the savings account at the end of the first year, we just times it by the multiplier, 0.1, 1.016. But we're told that it's for 7 years that it's going to be in there. So we then times it by 1.0167 times, or easier way of doing it is 1.016 to the power of 7. When we do that, we get 2,682.052 blah blah blah, and because it's money, we round to the nearest pence, so 2,682.05. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So when we find the mean of something, we add the elements together and we divide them by the amount of elements. So here we've got 3 elements. So what we're going to do is add these together and then divide by 3. Now the problem is that the denominators are not the same, so we can't add them yet. But they're all factors of 45. So we're going to times top and bottom of the first one by 9. So we end up with 9k over 45. We're going to times the top and bottom by 3. And so it would be 3 brackets k plus 1 over 45. And the last one is over 45, so we don't need to do anything for that. Then we can just add the numerators together. And I'm just going to expand the bracket here, so it's 3k plus 3 plus k plus 4. And then all of that over 45. And then we're going to do 9k plus 3k plus k, which is going to be 13k. And then 3 plus 4, which is just 7, over 45. So the sum of them is 13k plus 7 over 45. So to work out the mean, we need to divide it by 3. But instead of writing divide by 3, we know KFC, keep, flip, change. If you have a division, you keep the first fraction, you change the divide into a times, and you flip the second fraction. So a different and easier way of writing that is times 1/3. So here we just keep the numerator the same because we're timesing it by 1. And then the bottom we just times by the 3, which would be 135. So our answer is 13k plus 7 over 135. We've got to first of all work out how many jumps there is between our shape and the centre of enlargement. So I'm going to pick a point at the top of our shape, and we can see that there are 2 jumps to the left, and 1, 2, 3, 4, 5, 6. So we've got to go 2 and then 6. And the reason we do this is we're looking at a scale factor of -2, which means we're going to go through the centre of enlargement. And what that means is we're going to do 2 left and 6 down another 2 times because it's -2. So we're going to go 1 and 2, 1, 2, 3, 4, 5, 6. And that would be a scale factor of -1 if I plotted that point. We're at -2, so we're going to go another 2, 1, 2, and another 6. 1, 2, 3, 4, 5, 6. So our new coordinate is down there. And we can go ahead and do this for the other 3 coordinates. I'm going to do it for the bottom left point. So we go 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So the coordinate's going to be there. Now I can do it for the third one, or I can just kind of work out where it's going to be. Because if I draw in this shape, well, we've got the 2 coordinates here. So it's kind of on the y-axis. You can't really see it too well. But we know the other one is going to be 4 to the left, because on our original image it's 2 to the right. And so a scale factor of -2 would be, instead of 2 to the right, if you negate that, it's going to be left, and if you times it by 2, it's going to be 4. And let's just draw in our last part of it, and that's going to be our new triangle there. And it says to label it B, so we're just going to put B on it. So we notice on the simultaneous equations that the coefficient of the y's and the x's are different. I always focus on the y's and make sure they're the same. So we've got to make them the same, ignoring the sign. So we've got a -2 and a +3. So to make them the same, well, 2 and 3, the lowest common multiple of 2 and 3 is 6. So we've got to make them both 6. So we're going to do 6x and -2y equals -21. And we're just going to multiply everything by 3 to make the coefficient of the y's the same. Times them all by 3. And we get 18x minus 6y, which is good, so that's what we're looking for. And that's going to equal -63. On the second equation, I'll write that out. 7x plus 3y equals -1/2. And this time we're going to times everything by 2. So times all the terms by 2. And we get 14x plus 6y, which is good, so that's what we wanted, and equal -1. So I'm going to write these in together. So I'm just going to copy the same equations again, but we're just going to have them next to each other so we can start working our simultaneous equation magic on them. And we're going to get our circles going downwards. Remember, simultaneous equations are all about going downwards. Make sure the signs go with the y. Now we've got to work out what sign we're using here. And the way I remember it is looking at the y's, because that's the thing we're trying to deal with, we're trying to get rid of. Looking at the signs, if the signs are the same, we subtract. If they're different, we add. So looking at the signs, there's a negative and there's a positive, so they are different, so we're going to add. So we're going to add the y's together, but we've got to do the same to all of them. So we're going to add the 18x and the 14x, we're going to add the 63 and the -1. So going downwards, and let's draw a neat little line to show that we're working out the sums. So we've got 18x plus 14x, which is 32x. We've got 6y minus 6y plus 6y. The two pluses make a plus, so it's -6y plus 6y, which is nothing, which is good. That's what we're trying to do, is get rid of the y's. And then we've got -63 plus minus, which just makes a minus. So it's -63 minus 1, which would be -64. Then we go just quickly solve. That's going to be nice and easy because we're just going to divide both sides by 32 to get x on its own. So we've got x equals -64 divided by 32, which would be -2. So x is -2, but we can't stop there because we need to find out what y is. So what we're going to do is go to the original equation, and we're just going to substitute in the x for -2. So we're going to do 6 times -2. -2y equals -21. So 6 times -2 is just going to be -12. Add 12 both sides, and that will give us -2y is equal to -9. Then we've got a -2y as the coefficient of the y, so we need to divide both sides by -2y. The two minuses will get rid of each other, so it's 9 divided by 2, which is going to be 4.5. And we can check this by putting the x and the y into the other equation and see whether we get the answer of minus 0.5. To find the interquartile range from a cumulative frequency graph, you first of all see what the graph goes up to. Here you can see it goes up to 20. And what we do is we halve that, and that's the value we use to find the median. So we halve that again, and that's the value we find for the lower quartile, which will be 5. Then you add the 5 to the 10, so the number we use for the lower quartile to the number we use for the median, and we get 15. So those are the 2 points there that we will find our quartiles. So we draw a line across to find our lower quartile, a line across and down, and I think that is roughly, I think 22 roughly. We do the same again for our upper quartile. Line across and down. And that's roughly, I mean, these are going up in 4s, so maybe 37. Because this line here would be 36, so that would be 37. So to find the interquartile range, it is interquartile range, let's do the formula, is the upper quartile, take away the lower quartile. Upper quartile is 37, lower quartile we said is 22, and so 37 take away 22 is going to be 15. Now if you've got slightly different values, that's absolutely fine. The exam will always give a bit of leeway, especially when reading off graphs. To find the length of the rectangle, what we're going to do is we're going to get the area and we're going to divide it by the width. Now, the question says that it wants the minimum length, so we want the length to be as small as possible. Obviously, to do that, we want the area to be as small as possible. If the area is smaller, the length will be smaller. But let's have a look at a couple of fractions. So let's have a look at a half and 1 over 100. Which one of those fractions is the smallest? Well, it's 1 over 100, but what do you notice about the denominator? That as the denominator gets bigger, the fraction gets smaller. So to make something smaller, we actually want the denominator to be as big as possible. So we want the width to be as large as possible. So we're going to find the lower bound of the area. And an easy way to find a lower bound is find the accuracy. Well, it says the accuracy is to the nearest 10. And what we're going to do is halve that. So half of 10 is 5. And then we're going to take it away from the area. So it's 98,540, take away 5, which will be 98,535. Now for the width, we're going to do the same thing, half the accuracy, half of 10 is 5, but we're looking for the upper bound, we're looking for the biggest it can be. So we're going to add that on, 1, 2, 3, 5. And when you do that calculation, you get the answer of 79.78542, blah, blah. And it says it wants it to 4 decimal places. So we're going to do 79.7854. So we're going to start by finding the multiplier. So we start off with 100%. It says it's decreasing at a rate of 8.1%. So we're going to take away the 8.1%. And then when we do that, we get 91.9%. Make that a multiplier by dividing it by 100, essentially making it a decimal. So whenever we get a number and we times it by 0.919, we're decreasing it by 8.1%. Now, there aren't any amounts given to us in this question, so we're just going to make one up. We're going to say that the population is 100. Okay, and what we're going to do is type in 100 into our calculator, and then we're going to press the equals button. Now what that does is it stores the 100 in the calculator's memory, and it's basically, it's this next line that's the crucial bit. We're going to type in answer, which at the moment is that 100, times 0.919. And what that does is it says what the current answer is, we're going to decrease it by 8.1%. We're going to times it by that multiplier. And so every time we press the equals button, what it's going to do is it's just going to keep decreasing it by 8.1%. And we're going to count the amount of times we've got to press the equals button, because every time we press the equals button, it counts as a year. So when we first press it, it's going to be 91.9. Then press it again, it's going to be 84.4. So we're waiting for it to be beneath 43%. So if we started off with 100, we're looking for it to be below 43. So keep pressing it, keep pressing it. On the 9th year, we get 46.7, so that's close to that 43. Press it again, and we get 42.9. So it's 10 years. It's 10 times you've got to press it to get it beneath the 43. We're going to write this out again just to give us a bit more space. So we've got S equals 4 minus 13t over t minus 5. I'm going to get our lines in. Okay, so the first thing I need to do is get rid of this fraction. Always get rid of any fractions. I'm going to do that by multiplying both sides by t minus 5. So we're going to end up with s brackets t minus 5 equals 4 minus 13t. I'm going to break open those brackets just by multiplying them out. So it's st minus 5s equals 4 minus 13t. And the objective here is to get all the t's on the same side. So I'm going to add the 5s and I'm going to add the 13t. So add 5s and then add 13t. And so effectively we're just moving this on the other side and this on the other side. So we're left with st plus 13t equals 4 plus 5s. Now when we've got the t's on the same side, we can factorise out the t's. So t bracket s plus 13 equals 4 plus 5s. And then we can get rid of this by dividing both sides by s plus 13. And so we're left with t equals 4 plus 5s over s plus 13. So our answer is 4 plus 5s, all of that over s plus 13. And it can be either way around, so I could have 5s plus 4 over 13 plus s, or anything like that. We can write the equation of any linear graph as y equals mx plus c. So m is the gradient and c is the y-intercept. So we've got to find what the gradient and the y-intercept are. Well, I'm going to first of all try and figure out what the gradient is, because we're actually given some clues here. We're told that the line is perpendicular to the equation given. Now I'm going to rewrite this a little bit just to make it a bit clearer what the gradient of this is. So I'm going to write this as minus 1 over 12. I'm just going to leave a bit more of a gap there. Minus 1 over 12 x plus 12. And you can see that the number before the x, the coefficient of the x, is minus 1 over 12. But we're not told that it's parallel to that, so it's not, the equation that we've got is not going to have the gradient as minus 1 over 12. We're told it's perpendicular. Now, when two things are perpendicular, to find the gradient of the other one, if we know one of them, you've got to change the sign and find the reciprocal of the fraction. So to find our gradient, we're going to change the sign, so it's negative, so our gradient is going to be positive, and we're going to flip it. We're going to find the reciprocal. Reciprocal of 1 over 12 will be 12 over 1, or just 12. So the gradient of our line is going to be 12. To find the y-intercept, we're going to use the points given to us. So we've got x equals 3 and y equals 4 for a point on our line. We're going to substitute those into the equation we've got. So it's going to be 40 equals 12 times 3 plus c. Put in our solving lines. 12 times 3 is 36. And we're going to take away that 36 both sides. So it's going to be 4 equals c, or c equals 4. So our equation will be y equals 12x plus 4. When asked to simplify a fraction, we need to find a factor at the top and the bottom of the fraction to divide out. So we're going to start by factorising these fractions, and I'm not going to go into how to factorise quadratics because we've got plenty of other videos on the site that go into that. But when you factorise the top, you get 3x plus 4 and x minus 5. And when you factorise the bottom, you get 2x minus 1 and x minus 5. Now, it's not a coincidence we have the x minus 5 at the top and the x minus 5 at the bottom, because we're just going to divide that out to simplify the fraction. So we're just going to divide that out. That will make that convert it into 1, and 3x plus 4 times 1 is just 3x plus 4, and same with the bottom. So we end up with 3x plus 4 at the top and 2x minus 1 at the bottom. There are two shapes we're interested in this question. There's this sector here, which we can work out the area of, and there's this triangle here, which we can work out the area of. What we do is we work out the area of the sector and then we subtract the area of the triangle. So I'm going to start off by working out the area of sector. And we know that that is the angle that we have of the circle times by the area of the full circle. So the angle we have is 39 over 360. And then we've got pi times 10 squared. Type that into your calculator and you get 34.033 blah blah blah. Next we're going to find out the area of the triangle. And we use the, well, if you have a look at the triangle, we've got 10 centimeters here because that is also a radius of the circle. So we've got two lengths and we've got an angle, so we can use the half AB sine C formula. So we've got half AB sine C. And so A and B are going to be our lengths, and C is going to be this angle here. So we've got a half times 10 times 10 times sine the angle, which is 39. Then when you work that out, you get 31.466 blah blah blah. Okay, so to work out the area of the segment, all we're doing is the area of the sector, like the full area, take away the bit we don't want, which is the triangle, and that will leave us the area of the segment. So we're going to do the 34.033 blah blah blah, take away 31.466 blah blah blah. And what I've done is I've saved them on my calculator so I can do it precisely. And when you subtract them, you get 2.567 blah blah blah. Once it's two decimal places, so we're just going to round that to 2.57. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got two radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagram as 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realizing is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got three of the sides, we can work out the last one. So angle DOB is going to be 360, take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360, take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360, take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference. And the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead. And we've got three of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know. So the 228, the 13, and the 66. And the reason being the same as before. So angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. I'm going to start off this question by finding length BD. And we do that by doing a little right angle triangle down here. And let's draw that right angle triangle out. Okay, so we've got a length of 4 on ED, length of 3 on BE, and we're looking for length BD. So we're going to use Pythagoras. So we've got BD squared equals BE squared plus ED squared. Get our little tram lines in. Okay, so BE is 3, so it's going to be 3 squared plus 4 squared, and that's going to equal 25. Square root both sides, and we've got BD is equal to square root of 25, which is just 5. Okay, we need to now work out what MD is, because we're looking for length AM. So MD is actually just going to be half of BD. So it's going to be half of 5, which is just going to be 2.5. The reason for that is that all of the lengths AB, AC, AD, AE, all of them are the same, so therefore point A will be exactly at the midpoint or above the midpoint of the square, so M is obviously at the midpoint. Okay, next we're going to draw in another right angle triangle. It doesn't actually matter which side we take. We're just going to take this side because we've worked out what MD is. And let's draw that out down here. Okay, so we've got the length of 5 here. We know the bottom bit is 2.5 and we're looking for the length AM. So another bit of Pythagoras here. So AM squared is going to equal, and we're looking for AM, yep. AM squared is going to equal AD squared, take away MD squared, and AD squared is going to be 5 squared minus 2.5 squared, which is going to equal 18.75. Then we'll square root both sides. I haven't put my tram lines in. Let's get those in as well. Make sure it's all neat and tidy. So we've got AM is equal to 4.330, and because it says 2 decimal places, we want to write down the answer 4.33 centimeters. A simple trick when you're finding the inverse of a function is to replace or to switch the y and the x. Now we don't actually have a y in here, but we can just put one in, it's not a problem. So we can just rewrite this function as y equals x over 10 minus 11. And we're just going to switch around the y and the x. So x equals y over 10 minus 11. Now the objective now is to get the y on its own, to make y the subject. So we're going to first of all add the 11 both sides. And I've made an amateur move here. I've not left myself enough room, so let's just scoot that across. Okay, so add the 11, so it would be x plus 11 equals y over 10. Next thing we're going to do is multiply by the 10 to get y on its own. So it would be 10 brackets x plus 11 equals y. Expand those would be 10x plus 110 equals y. Now this doesn't equal y. We are looking for the inverse function with this notation here. So we just replace the y with this notation and we get 10x plus 110. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.